Welcome back to the CompTIA SecurityX video series. In this video, we are going to cover an important topic from the security engineering domain: how to enhance the security of endpoints and servers. This includes understanding several core tools and practices such as application control, endpoint detection and response, event logging and monitoring, endpoint privilege management, attack surface monitoring, HIPS and HIDS, anti-malware solutions, SELinux, host-based firewalls, and browser isolation. Let's begin. First, let's talk about application control. This technique allows organizations to control which applications can and cannot run on their systems. There are two primary methods. Whitelisting permits only pre-approved applications, meaning anything not on a list is automatically blocked. Blacklisting, on the other hand, blocks known harmful applications. For instance, a company may allow only Microsoft Office and its internal apps while blocking peer-to-peer file sharing software. This control limits the chances of users executing malicious or unapproved programs. Now let's move on to endpoint detection and response, or EDR. EDR tools continuously monitor endpoint activities to detect suspicious behavior and respond to potential threats in real time. EDR tools collect data on processes, network connections, and file changes. If abnormal behavior is detected, such as a user launching PowerShell script to download data from the internet, EDR can alert the security team or even stop the activity automatically. Popular examples include CrowdStrike and SentinelOne. Next is event logging and monitoring. This involves collecting logs from endpoints and servers and analyzing them for signs of malicious activity. Logs may include user login, file access, and system changes. These logs are sent to a centralized platform called a Security Information and Event Management System, or SIEM. Tools like Splunk or Yellow Stack can be used to detect anomalies, such as repeated failed login attempts, which might indicate a brute force attack. Moving on to endpoint privilege management. This practice ensures users and applications only have the privileges they need and nothing more. By limiting permissions, we reduce the impact of a compromised account. For example, a standard user should not be able to install software or access system files. If they need to install something, they can request temporary access, which can be monitored and revoked after the task is done. This principle of least privilege is enforced using tools like BeyondTrust or CyberArk. Now let's discuss attack surface monitoring and reduction. The attack surface includes all the possible points where an attacker could exploit your system. Reducing the attack surface means disabling unnecessary services, closing unused ports, and uninstalling software that is not needed. For example, if a company does not use FTP, the FTP service should be turned off to reduce risk. The fewer exposed points, the harder it is for attackers to get in. Host-based intrusion prevention and detection systems come next. HIDS tools like OSSEC monitor the system for suspicious activity and alert the administrators. HIPS tools go a step further and can block malicious actions automatically. For instance, if a process suddenly attempts to change system configuration files, HIPS can prevent it from doing so, protecting the integrity of the system. Now on to anti-malware. This is a classic defense against known threats like viruses, worms, and ransomware. Anti-malware software uses signatures and behavior analysis to detect and remove malicious code. For example, if a user accidentally opens a malicious email attachment, the anti-malware tool will scan the file, identify the threat, and quarantine it before it causes harm. Next is Security Enhanced Linux, or SELinux. SELinux is a security feature built into Linux systems that enforces strict access controls. Even if a user or application has traditional permissions, SELinux can restrict access based on policies. For example, if a web server is compromised, SELinux can prevent the attacker from accessing files outside the web directory. It acts as a powerful defense layer, particularly in enterprise environments. Host-based firewalls are another essential tool. These firewalls are installed directly on servers or endpoints and are used to control incoming and outgoing network traffic. For example, you can configure a host firewall to block all incoming connections except for those on port 443 for secure web traffic. This limits the exposure of the device to external threats. Finally, let's cover browser isolation. This security measure separates the browser from the rest of the system, usually by running it in a container or virtual environment. This means that if a user visits a malicious website, the threats are contained and cannot affect the underlying system. For example, some organizations use remote browser isolation platforms that open websites in a cloud environment and stream only safe content back to the user. To summarize, securing endpoints and servers requires a layered approach. Each of these tools plays a critical role in building a resilient security architecture. By implementing application control, using EDR, monitoring logs, managing privileges, reducing the attack surface, deploying HIPS and HIDS, running anti-malware, using SELinux, configuring host-based firewalls, and isolating browsers, organizations can significantly strengthen their defense against modern cyber threats. Thank you for watching. In the next video, we will explore more topics from the SecurityX series. Make sure to like, share, and subscribe to stay updated.